And once again, we are back together. All right, we are still continuing on that technical maths DBE May-June 2024 exam. So please, if you haven't subscribed, make sure you are part of this family. All right, so we are looking at question 4. Right, they say given functions f and h defined by f of x is negative 2 into x minus 3 all squared. This is plus 18. Right, now you would know in this case that this is a parabola, right? So whenever they give us a parabola in this form, remember this is the x value of our turning point, and this would represent the y value of our turning point. So we already know that, okay? And h of x, which is 2x plus c, that's a linear function. So they say to us, write down the coordinates of the turning point, right? Just like we said. So the coordinates of the turning point in this case would be, right, please remember that for the x value, you always change the sign. So that would be positive 3. And for the y value, you keep the sign and the number. So that would be positive 3 and 18. Okay, right. Now they say to us, determine the x-intercepts of f. So to keep in mind, for x-intercept, we know that y is equal to 0. Okay, so this is where f of x must be equal to 0. Okay, so it means that we're going to say negative 2 into x minus 3 all squared plus 18 is equal to 0. Right, so going to say negative 2 into x minus 3 all squared is equal to negative 18. So let's divide both sides by negative 2. So we've got x minus 3 all squared, and negative 18 divided by negative 2 is 9. Okay, so we've got x minus 3 is equal to, and please I want you guys to note we are taking the square root on both sides, but what do we need to do? Say plus or minus. So that's plus or minus 3, right? And what do we have ultimately? We've got x minus 3 is equal to positive 3, or you've got x minus 3 is equal to negative 3. And you'll see that we've got x is equal to 6, or x is equal to 0. Right, so those are the two values that I get. So which means our 2x-intercept would be 0 and 0, right? Please note, this is at the x-intercept. So our y value is always 0 at the x-intercept, as well as 6 and 0. So those are the two x-intercepts that we have. Right, now they say to us, hence, sketch the graph of f on the answer sheet provided. Okay, clearly show the intercepts with the axes and coordinates of the turning point of f. So, what would our graph look like? So firstly, we also need the y-intercept because they said we must show all intercepts, right? So I'm going to say, so for the y-intercept, we know that x is equal to 0. So which means we're going to take f of 0. That's minus 2 into 0 minus 3 squared. This is plus 18. So something that you should note, that's negative 2. Now, please, guys, I want you to note in this case, I've got negative 3 all squared, right? And that would give us 9. That's plus 18. And so it looks like our y-intercept is 0 and 0 again. So what I'm going to do, let's draw the graph. So I'm going to start with the x-intercepts. That's at 0. and that is at 6. Okay, so our graph, please, I want you to note our y-intercept, okay, or rather our turning point is at 3 and 18. So let's put 3 and 18 somewhere over there. And so our parabola looks something like this. Okay, right. All right, this thing is, there we go. Right, that looks much better. Okay, so we're showing this value 0, and this one is 6, and this one is 3 and 18. All right, and that's our graph for f of x. Okay, so that is truly what the graph looks like. Now they say to us, A is a point 5 and t is a point of intersection of f and h. Calculate the numerical value of t. All right, so if it is a point of intersection, which means that we need to find the value of t by simply saying f of 5. Everywhere we see x, we're going to substitute 5. So that would be 5 minus 3 all squared plus 18. And so what are we going to get there? That's going to be negative 2. 5 minus 3 is 2. 2 squared is 4 plus 18. I know some of you would have given up and just quickly went for your calculators, right? So this would be equal to 10. Right, so the value of t is 10. All right, so that will be 10. So they say, hence, determine the numerical value of c. So remember, they did say that that value there, A, is the point of intersection of both f and h, right? So to get the value of c, all I'm going to say is I know at least one point that the graph passes through. So I know when h, or rather when x is 5, h of 5, that would be 2 times 5 plus c, right? H of 5 is equal to 10. And so for my c value, that would be equal to 10 minus 10, and that would be equal to 0. So which means c is equal to 0. All right. Now, let's find the next point. Okay, so they say to us, sketch the graph of h on the same set of axes. On the answer sheet provided, clearly show the intercepts with the axes and the coordinates of A. All right, so firstly, it looks like the y-intercept of this graph is simply going to be at 0. In fact, let me just use a different color. Right, it's going to be at 0. But what else do I know? I know that it passes through the point where we've got 5 and 10, right? So let me just put that point over there. That's the point 5 and 10. That's A, which is 5 and 10. And what does our graph look like? This would be our graph. Okay, so this would be the graph of h of x. Right, and that is truly how the cookie crumbles, ladies and gents. And of course, you could have found out what the y-intercept, x-intercept, but you are quickly going to realize that they are 0 and 0. Our y-intercept, we already got it there in this case because our c value is equal to 0, right? So that is it on this question. We're going to continue with the next portion, which is the next graph. For now, I'll see you guys next time. Sharp, sharp.